It's good to have you with us tonight. Look up, if only in your mind, at the ordinary things you carry, the calcium holding your bones together, the iron riding quietly through your blood. They feel like the smallest, most personal parts of you, closer than your own name. Yet not one of them was made here on Earth. Everyone was forged in the heart of a star. The pressures and temperatures, there are ones the planet has never known. Then they were scattered across empty space, long before there were oceans, or seasons, or anyone left to wonder about them. Those atoms traveled for billions of years before they became you. So how did the inside of a dying star end up inside of you tonight? Settle into the dark, where the heaviest elements ever made are still drifting between the stars. The same slow drift that carried them over unimaginable time into everything you are, patient and unhurried, asking nothing of you now. Welcome to Sleepy Science Facts. Let one quiet question travel with us, out toward the stars, and gently back again. Why might understanding the death of a star be the very thing that makes your own small life feel less lonely and more worth holding? Underneath everything we follow tonight rests one quiet question, and it begins with the calcium in your bones. That calcium did not start here on Earth. It was forged inside stars that lived and died long before our sun existed, then scattered across space when those stars came apart. The iron carrying oxygen through your blood right now has the same history. So the gentle mystery we will sit with for these slow hours is this. Why might understanding the death of a distant star help you feel less alone in your own quiet life? Hold that question loosely. We are only opening it tonight, not answering it yet. Let it rest in the back of your mind like a far light. The sun you see each morning is an ordinary star, one of hundreds of billions in our galaxy. It looks special only because it is close. Light from its surface takes about 8 minutes and 20 seconds to cross the 93 million miles to your eyes, confirmed by NASA's tracking of the Earth-Sun distance. So the sunlight, warming your face, left the sun before you woke, before you rose, before this evening began. You are always seeing the sun a little in the past. Even the nearest star in your sky is already a memory by the time it reaches you, a soft reminder that the heavens speak to us slowly, on their own unhurried clock. The moon, the gentlest light in your night sky, is drifting away from Earth. Laser measurements bounced off mirrors left by Apollo astronauts show it recedes about 1.5 inches each year, roughly the slow rate at which your fingernails grow. It was once far closer, hanging larger and brighter over an ancient Earth no human ever saw. Tonight, it is the most familiar object in the dark, yet it is quietly leaving, year by year, too slowly for any single life to notice. There is something tender in that. The sky you know is not fixed. It is in motion, and it has been keeping you company through all of it, without ever asking anything from you. every atom in the moon, the Earth, and your own hands was once part of a cloud of gas and dust floating in space. Astronomers call these stellar nurseries, and the Hubble and James Webb telescopes have photographed many of them, glowing softly where new stars are being born. Our solar system condensed from one such cloud about 4.5 billion years ago. The dust in that cloud already carried the ash of earlier, dead stars. So the familiar ground beneath you is recycled starlight, gathered and pressed into rock and water and bone. You live on the remains of stars, walking each day across a world that was once scattered through the dark. The planets you can sometimes spot with the naked eye: Venus, Mars, Jupiter, Saturn, are your nearest neighbors, yet they are unimaginably far. Light from Jupiter takes around 40 minutes to reach you when the planet is near. They formed alongside Earth from the same swirling disk of leftover material around the young sun, a picture confirmed by observations of similar disks around other stars. They are made of the same kinds of atoms you are, the same elements arranged differently. When you glimpse a bright point of light at dusk and learn it is a planet, you are seeing a relative, a fellow piece of that ancient cloud, lit by the same sun that lights you. The stars scattered across a clear night sky are suns, many far larger and brighter than ours. Their light has traveled for years, centuries, sometimes thousands of years to reach you. The familiar star Betelgeuse in Orion is so distant that the light entering your eyes tonight left it centuries ago. You are not seeing the star as it is. You are seeing it as it was. Some of the stars you admire may have already changed beyond recognition. And yet there they shine, steady and patient, sending their old light across the emptiness to land. At last, on a single person looking up, the sky is a gathering of messages, all of them in the past. The band of faint light arching across the darkest skies is the Milky Way, the combined glow of billions of distant stars in our own galaxy, seen edge-on. For most of human history, every person who ever lived could see it. Today, light pollution hides it from much of the world, which is part of why so many feel disconnected from the sky. But it is still there, every night, wheeling slowly overhead. Our sun is one quiet member of that vast, turning disk, carrying Earth and you along with it. When you do find a dark enough place to see that pale river of stars, you are looking at the home you have always belonged to. Almost everything you can touch is made of just a handful of elements that were cooked inside stars. Carbon, oxygen, nitrogen, calcium, iron. These were not present when the universe began. The earliest universe held mostly hydrogen and helium, the two simplest elements, confirmed by measurements of the oldest light in the cosmos. Everything heavier was built later, inside stars. This means the question we opened is already shifting a little. If the elements of your body did not exist at the beginning, then something had to make them. Stars are the only furnaces hot enough to do it. The story of your atoms and the story of the stars may be the very same story, still unfolding. The Big Bang Theory, supported by overwhelming evidence, describes the universe beginning about 13.8 billion years ago, expanding and cooling from an extremely hot, denser state. We know its age from the expansion rate and from the faint afterglow that still fills all of space, measured precisely by the Planck satellite. In those first minutes, only hydrogen, helium, and a trace of lithium formed. Picture that early cosmos. Simple, bright, and almost empty of the ingredients of life. None of the calcium in your bones existed yet. None of the iron in your blood. The universe had to grow old enough, and stars had to live and die before anything like you became possible. The light you cannot see still surrounds you, and the oldest of it tells the universe's deepest secrets. Spread across the entire sky is the cosmic microwave background, the cool remnant of the heat from the Big Bang itself. It is the most ancient light there is, released when the universe was only a few 100,000 years old. Detectors have mapped it across the whole sky, and it matches the predictions of the Big Bang with remarkable precision. That faint, even glow is, in a real sense, a baby photograph of the cosmos. And here is the quiet thread to hold. The universe that made this picture is the same universe that, much later, made you. Stars are not eternal. Like everything else, they are born, they live, and they die. On timescales so long, they seem changeless to us. Our sun has been shining for about 4.5 billion years and has roughly 5 billion more before it runs out of fuel. A star's whole life is a slow, steady balance between gravity pulling it inward and the heat of fusion pushing it outward. As long as that balance holds, the star shines. When the fuel runs low, the balance breaks, and the star begins to die. Tonight, you can rest in this. Even the steadiest light in the sky is living out a life in no hurry, on a scale your worries cannot reach. Deep in a star's core, hydrogen atoms are pressed together so hard that they fuse into helium, releasing enormous energy. This is nuclear fusion, the process that powers every star, including our sun. The pressure and heat needed are almost beyond imagining. Tens of millions of degrees, recreated only briefly in human laboratories. Each second, the sun converts millions of tons of matter into pure energy, a fraction of which becomes the sunlight on your skin. So, the warmth you have felt your whole life is the direct result of atoms merging in a furnace 93 million miles away. The same kind of fusion, in stars, long dead, is what made the atoms now reading these words. The first generation of stars formed from nothing but hydrogen and helium, the only building materials the young universe offered. These earliest stars were likely enormous, far larger than our sun, burning fiercely and living fast. Inside them, fusion began stitching the first carbon, the first oxygen, made anywhere in the universe. Astronomers search for traces of these ancient stars in the most distant, oldest light the great telescopes can gather. They were the first furnaces, the first makers of the elements that would one day become planets and people. Before them, the cosmos held no ingredients for life. After them, the long work of building you had quietly begun. As a star ages, it builds heavier and heavier elements in layers, like the rings of an onion. First, hydrogen fuses to helium, then helium to carbon and oxygen, then on to heavier elements still, each stage burning hotter than the last. This sequence is well established in physics and confirmed by the light spectra of stars at different life stages. The carbon in your cells and the oxygen in every breath you take were assembled in exactly this way, deep inside stars that finished this work long ago. Your body is, quite literally, a collection of these stellar layers, gathered up and given a heartbeat. The furnace that made you cool to ash before the Earth was born. When a medium-sized star, like our Sun, reaches the end of its life, it swells into a red giant, then gently sheds its outer layers into space. These glowing shells are called planetary nebulae, and telescopes have captured hundreds of them, delicate and luminous, like cosmic smoke rings. This is not a violent end, but a slow, graceful exhale, releasing carbon, oxygen, and nitrogen back into the galaxy. Those scattered elements drift for ages, then gather into new clouds, new stars, new worlds. Much of the carbon that makes up your body may have come from such a quiet death. The end of one star becomes the raw material of everything that follows, including, in time, you. The largest stars die very differently, in an event called a supernova, one of the most powerful explosions the universe allows. When such a star exhausts its fuel, its core collapses in an instant, then rebounds in a blast so bright that for weeks it can rival the light of a whole galaxy. Astronomers have recorded these explosions for centuries, including one in the year 1054 that Chinese observers saw in daylight. In that single moment of collapse and fire, elements heavier than iron are forged and flung across space. Gold, silver, and much more are born in this stellar death. The most catastrophic ending a star can have is also the most creative. Destruction and creation in the cosmos are the same act. The iron carrying oxygen through your blood right now was made inside a dying star and released in its death. Iron is where a star's ordinary fusion reaches its natural limit, the place where the furnace can no longer feed itself. Beyond iron, making heavier elements takes energy rather than releasing it, so the star's core fails and collapses. This is well established in nuclear astrophysics. Every iron atom in your body, in every red blood cell, was forged in stellar fire and scattered when that star died. The metal that lets you breathe came from an ending you will never see. You are carrying, in your own veins, the quiet inheritance of a star that gave everything it had. When a star's outer layers are blasted into space, they do not vanish. They spread out into vast, glowing clouds of gas and dust, enriched with all the new elements that star created. The Crab Nebula, photographed in extraordinary detail by Hubble, is the still expanding wreckage of that supernova seen in 1054, and it is rich with heavy elements. These clouds slowly drift and mix with the thin gas already floating between the stars. Over millions of years they cool and gather. Given enough time and gravity, they begin to collapse again into new stars and new planets. The death of one star quietly seeds the birth of the next. Nothing in this cycle is wasted, and nothing is ever truly lost. Our own solar system was built from such enriched material, the leftover ash of earlier stars. The presence of heavy elements like gold and uranium in the Earth proves it. These elements can only be made in dying massive stars and certain stellar collisions, never in a star's ordinary life. So their very existence in our planet is evidence that, before the Sun formed, other stars lived, died, and gave up their substance to make this place possible. You are standing on the recycled remains of stellar deaths far older than the Sun. The familiar weight of the ground, the gold in a ring, the stone in the hills, all of it once burned in stars that ended so this world could begin. The phrase that you are made of stardust is not poetry alone. It is measured chemistry. The Earth and everything on it, including your body, is built mostly from elements forged in stars. The oxygen you breathe, the carbon in your cells, the calcium in your bones, the iron in your blood. Only the simplest hydrogen in you traces back to the Big Bang itself. The rest is stellar manufacture. This is the settled understanding of modern astronomy, drawn from spectroscopy, nuclear physics, and the study of stars across their lifespans. When you place a hand over your heart and feel it beating, you are feeling atoms that were once at the center of a star. The cosmos did not just make a place for you, it made you out of itself. The atoms that compose you are astonishingly old. The hydrogen in you has existed since not long after the Big Bang, and the heavier elements for billions of years, made in stars. Your body is new, but its raw material is among the oldest matter in existence. These atoms have been part of countless things before you. Ancient seas, vanished forests, other living creatures, even other stars. They were simply gathered, for a while, into the particular pattern that is you. When this life is over, they will scatter again and become part of something else. You are not a fixed object, so much as a passing arrangement of very old dust, briefly awake, briefly aware. Looking up at the sky, it came from. Consider how unlikely and precious your particular gathering of atoms is. For you to exist, the universe had to be old enough that stars had lived and died many times over, seeding space with the right elements. A cloud had to collapse into our sun. A planet had to form at the right distance for liquid water. Life had to begin and continue, unbroken, for billions of years. Each step is documented in the geological and astronomical record. You are the end point, Sofar, of a chain of cosmic events 13.8 billion years long. The odds against this exact arrangement of stardust waking up as you are beyond counting. And yet here you are, breathing in the dark, real and warm and alive. The same stars that made your atoms also made the atoms of everyone you have ever known and everyone you never will. Every person, every animal, every tree shares this single origin in the ancient deaths of stars. The carbon in a stranger's hand and the carbon in yours came from the same kind of furnace, possibly from the very same dead star. This is the literal, physical meaning of being related. Beneath all the distance that can grow between people, there is a shared substance, a common dust. The loneliness that can settle over a quiet evening is real, but it is not the whole truth. At the level of your atoms, you have never once been separate from anything else that exists. The light from the stars whose deaths created your elements may still be traveling through space. Even now, light is slow against the vastness of the cosmos, and the universe is so large that ancient signals are still arriving. Some of the very stars that contributed to the cloud that made our sun ended their lives so long ago that we will never see them. But the principle holds, established across all of astronomy. The sky is full of old light from old fires, some of which had a hand in making you. When you look up, you are not separate from what you see. You are looking at the kind of furnace your own body came out of, still glowing in the dark. So the familiar sky, the sun, the moon, the scattered stars, turns out to be far stranger and far closer to you than it first appeared. It is not a distant decoration above your life. It is your origin, your factory, your family of furnaces. The question we opened is beginning to turn in our hands. We asked why the death of a star might help you feel less alone, and already the answer is gathering. Because those deaths are written into your bones and your blood. There is far more to follow, deeper and stranger machinery ahead, before the full meaning of this settles. But for now, simply rest in the nearness of it. The sky you grew up under has been part of you all along. The iron you just heard about, made in a dying star and now carrying breath through your blood, is moving in you this very moment. with no effort from you at all. The question we opened has started to turn quietly. The distance you sometimes feel from the world may be far smaller than it seems, because the world and you are made of the same scattered fire. Let that settle into your chest, slow and unforced. This is not something to figure out. It is simply true, happening inside you as you lie here. Take one easy breath and let it go all the way out. From here, the sky only grows deeper, and we drift further in together. If these slow hours under the stars are helping you soften towards sleep, and you might let this channel stay with you on the quiet nights ahead. There is no need to do anything now. Simply rest, and let the rest of the journey carry you gently down into the dark. The atoms that make up your body did not always exist. In the first moments after the Big Bang, the early universe was far too hot for atoms to hold together at all. Only when it cooled, after about 380,000 years, could the simplest atoms finally form, almost entirely hydrogen, with a little helium. Everything heavier came later. So the calcium in your bones and the iron in your blood were not part of that first batch. They had to be built somewhere by some slow machinery you will spend tonight tracing. The starting material of you was the lightest, plainest stuff the cosmos had to offer, waiting to become something more. Stars are not just points of light. They are furnaces that forge new elements. Deep in a star's core, the pressure is so immense that hydrogen nuclei are squeezed together until they fuse into helium. This process is called nuclear fusion, and it releases the energy that makes a star shine. Our own sun fuses about 600 million tons of hydrogen every second. Each fusion welds light atoms into slightly heavier ones, and that heat is what holds the star up against its own gravity. The light warming your face on any clear day is the leftover glow of that quiet, ceaseless welding happening 93 million miles away. A star spends most of its life doing one patient thing: turning hydrogen into helium, drop by drop. This stable phase can last billions of years, and our sun is roughly halfway through its own. But fusion is not free. It slowly empties the core of its lightest fuel. As the hydrogen runs low, the balance between gravity pulling in and pressure pushing out begins to shift. Nothing about this is sudden. A star ages the way deep time measures everything. Without hurry, without alarm. The unhurried steadiness of a star is the first clue that the universe builds its most important things over spans that dwarf any single life. When a star exhausts the hydrogen in its core, it does not simply go out. Instead, gravity wins for a moment. The core contracts and heats, and fusion finds a new fuel. Now helium begins to fuse, forging carbon, the very element that forms the backbone of every living thing you have ever known. This is the first heavy element made in a star's final chapters. The carbon in your cells, in the food you ate today, in the breath leaving your lungs right now, was assembled inside a dying star's core. You are carrying the ashes of stellar exhaustion, reshaped into something that can wonder about where it came from. As a large star ages, it builds elements in layers, like the rings of an onion. Helium fuses into carbon, carbon into oxygen, oxygen into neon, then silicon, each shell hotter and denser than the one around it. Every new layer requires more extreme conditions, so only the most massive stars can climb this ladder. The oxygen you breathe and the silicon in the sand and glass around you were forged in these nested furnaces. What looks like a single point of light in the night sky is, on the inside, a structured factory running many reactions at once, quietly manufacturing the periodic table you are partly made of. The element building inside a star comes to a hard stop at iron. Fusing lighter elements releases energy, which is what keeps a star burning. But iron is the turning point. Fusing iron does not give energy back. It consumes it. So when a massive star's core fills with iron, the fire that held it up suddenly has nothing left to feed on. The support vanishes in less than a second. The iron in your blood, the metal carrying oxygen through your veins, this very moment, marks the exact boundary where an ancient star could no longer save itself. You hold inside you the element that ends stars. When the iron core can no longer hold itself up, gravity collapses it with staggering speed. In a fraction of a second, a core larger than Earth crushes down to a ball only a dozen miles across. The infalling material rebounds off this ultra-dense core and tears the star apart in a supernova, a burst of light so fierce that a single star briefly matches the glow of billions. This is not destruction for its own sake. It is the violent moment of release, when everything the star spent eons making is finally flung outward into space, scattered like seed across the dark. A supernova does more than scatter what a star already made. It creates new elements in the blast itself. The explosion's unimaginable heat and flood of particles forge metals heavier than iron, including some of the gold and silver that exist today. For an instant, the dying star becomes a forge hotter than its own core ever was. The wedding ring, the coin, the wiring in the device near you. Much of that heavy metal traces back to these final detonations. What feels permanent and earthly in your hands was born in the single most extreme event a star can have, then carried across light years to settle here. Not all heavy elements wait for a supernova. When two neutron stars, the ultra-dense corpses of earlier stellar deaths, spiral together and collide, they release a fountain of newly forged heavy elements into space. Astronomers confirmed this directly in 2017, watching gravitational waves and light arrive together from one such merger. Much of the gold and platinum in the universe was likely minted in these rare collisions. Even the densest, deadest remnants of stars are still building. The cosmos has more than one way to make the precious things, and every path runs through an ending that became a beginning. The space between stars is not truly empty. It is seeded with the debris of stellar deaths. Vast clouds of gas and dust, called nebulae, drift through galaxies, carrying the elements that exploding stars released long ago. These clouds are cold, dark, and immense, often spanning light years. They are the universe's holding grounds, where the scattered ashes of one generation of stars wait, slowly gathering. Nothing here is rushed or supervised. The material that would one day become the sun, the earth, and you spent ages adrift in such a cloud, simply existing in the quiet, until gravity began to gather it inward. New stars are born inside those drifting clouds when gravity pulls the gas and dust together. As a clump grows denser, it heats up, and if it gathers enough mass, fusion ignites at its center and a new star switches on. But not all the material becomes the star. The leftover dust and gas settle into a spinning disk around it. This is the recycling at the heart of the cosmos. The death of old stars supplies the raw material for new ones. Each star is built from the remains of those that came before, so that the very dust you are made of has likely passed through more than one stellar lifetime. Around our young sun, that leftover spinning disk is where the planets formed. Tiny grains of dust, the heavy elements forged in dead stars, stuck together, growing from specks to pebbles to boulders to worlds. Earth itself assembled this way, about 4.5 billion years ago, from the same enriched material as the sun. This is why the planet beneath you holds iron, carbon, oxygen, and gold at all. They were delivered by stars that died before the sun was lit. The ground you rest on tonight is not separate from the heavens. It is condensed starlight, gathered into a place solid enough to stand on. Your body is a meeting place of many vanished stars. The hydrogen in your water traces to the Big Bang itself, the carbon, oxygen, and nitrogen to stars that aged and shed their layers, the iron to a star that collapsed, the trace gold and iodine to supernovae or colliding neutron stars. No single star made you. You are an assembly, a gathering of contributions from countless stellar lifetimes spread across billions of years. When that one quiet question returns, why a star's death might make your own existence feel more precious, part of the answer is simply this: you are what their endings became. The atoms in you are almost unimaginably old. The hydrogen has existed for nearly the entire 13.8 billion year age of the universe. The heavier atoms were forged in stars that lived and died long before the sun and Earth even formed. By the time those atoms became part of a person, they had already spent most of cosmic history drifting, fusing, exploding, and gathering. You are roughly a few decades old. The material you are made of is older than the ground, older than the sun, nearly as old as everything. You are a very young arrangement of very ancient dust, briefly holding a shape that can look up and ask about its own beginning. Here is what these reactions have been quietly pointing toward all along. A star's death is not the opposite of your life. It is the source of it. The same physics that ends a star is the physics that supplies the iron, carbon, and calcium, without which no body could exist. The universe does not make new starting material from nothing. It makes it by letting stars finish. So the deaths you have been tracing are not far away or unrelated to you. They are upstream of every breath. The cosmos has been building toward you for billions of years, one ending at a time, though it has not yet shown you the whole of why that matters. That feeling of being small and unanchored in a vast world, hold it gently for a moment, because it is about to be answered by the very thing you are made of. The question still resting underneath everything tonight is why understanding the death of a star could make your own existence feel more precious, not less, and the elements you have just followed, from the core of a dying star into your own blood, are beginning to whisper their reply. The atoms now resting in your hands were forged in places that no longer exist. Most of the calcium in your bones and the iron in your blood was built inside massive stars, in furnaces that ran for millions of years before collapsing. When those stars died, they scattered their interiors across space, and some of that material eventually became you. Astronomers can measure these elements in old starlight and in meteorites alike, and the chemistry matches. What you carry tonight is older than the ground beneath your bed, older than the ocean, older than the sun. You are wearing the remains of suns that burned out long before this world was made. To build the iron in your blood, a star had to reach temperatures of several billion degrees, growing hotter still as its core neared collapse. Fusion stacks lighter elements into heavier ones, step by step, until iron forms in the core. But iron is where the building stops paying for itself. Making anything heavier costs more energy than it releases, so the core can no longer hold itself up. This process, measured in laboratories and confirmed in stellar models, decides how giant stars end. The metal that lets your blood carry oxygen is the same metal that marks the final breath of a dying sun. You hold the threshold where stars run out of fuel. Some of the heaviest metals humans prize did not form in an ordinary star's slow furnace at all, but in a single blink of cosmic violence. When two neutron stars spiral together and merge, the crash forges those elements in a few seconds. The amount produced in one such event can be measured in many times the mass of Earth, flung outward and scattered through the surrounding dark. So the rarest metals in the universe trace back to the rarest of cosmic events. Somewhere, in deep time, two ruined stars met, and a little of what they made drifted into the rock that became your home. When a distant supernova flares in another galaxy, its single dying star can briefly stand out against the combined light of everything around it. These explosions seed space with the elements that fusion built, flinging carbon, oxygen, and iron outward at thousands of miles per second. Observatories catch a few of these blasts in distant galaxies every year, and their light confirms what the elements inside you are made of. The brightest events in the cosmos are also the most generous. Each one is a star giving away everything it spent its life making, so that something else, somewhere, might one day breathe. The carbon at the center of every cell in your body owes its existence to a chain of reactions inside aging stars that almost fails at every step. First, 2 helium nuclei must fuse into a fleeting, unstable form of beryllium, and then a 3rd helium must strike it in the vanishing instant before it falls apart. Yet stars are patient and enormous, and across countless trillions of attempts, carbon accumulates. Physicists predicted this precise pathway before they ever confirmed it, simply because life made of carbon clearly exists. The element that frames your every thought tonight was assembled by chance, repeated past the edge of imagining, inside the slow hearts of dying stars. The oxygen filling your lungs with each quiet breath was made in stars far larger than the sun. Massive stars fuse oxygen during their final stages, then release it when they explode. It is the 3rd most abundant element in the universe, and roughly 2/3 of your body, by mass, is built from it. Every breath you take is a quiet exchange with the leftovers of stellar death. The same atoms have likely cycled through oceans, forests, and other living things across millions of years. You are not drawing in something new. You are borrowing, for a while, what countless stars and creatures have already used and let go. Almost every atom heavier than hydrogen and helium was made after the universe began, not at its birth. The Big Bang produced mostly the 2 lightest elements and little else. Everything richer, the calcium, the iron, the carbon that holds you together, had to be cooked later, in stars. Astronomers can read this history in the spectra of ancient stars, which carry far fewer heavy elements than younger ones like our Sun. The cosmos started simple and grew complex, one stellar generation at a time. You are made of late chapters, written long after the opening line, by stars that lived and died to enrich the emptiness. The Sun itself is a recycled star, built from the wreckage of earlier ones. Its chemistry shows traces of elements that only older, vanished stars could have made, which means our Sun is at least a 2nd or 3rd generation. The same is true of the cloud of gas and dust that became the planets and you. Every atom in your body has likely passed through more than one star before arriving here. You are not the first form this matter has taken, and you will not be the last. Tonight, you are simply its current shape, a brief gathering of borrowed pieces that have traveled farther than any mind can hold. The total number of atoms in your body is around 7 billion, 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 and nearly all of them were assembled inside stars. Each one is almost unimaginably old, often billions of years older than the Earth. They have drifted through cold space, fallen into clouds, been pressed into rock, and risen again into living things, over and over. The arrangement that is you has existed for only a flicker of that history. When this gathering loosens, as all gatherings do, those atoms will scatter and be taken up again. You are a pattern passing through matter that the universe keeps reusing without end. If you traced every atom in your body back to its source, the lines would fan out across the entire galaxy and into time so deep it has no clear flaw. No single star made you. You are a blend drawn from many, dead long before the sun ignited, their ashes mixed across light years and billions of years before settling into one breathing form. This is where the scale stops, feeling like distance, and starts feeling like belonging. The question that has followed us all night turns here. Perhaps understanding a star's death unsettles you less because you are small, and more because you finally see how far you reach. You just heard that no single star made you, that the matter holding you together was gathered from many deaths across the whole galaxy. Something in that can ache. The way being one small life among so many can feel like being lost in it. Notice where that quiet loneliness sits in you tonight, somewhere behind the chest, and let the breath move through it slowly, without trying to fix it. You do not have to feel large to feel held. The same matter that fills the sky is filling you right now, and it has never once been apart from the rest. Let that settle as we go deeper into the dark together. The atoms that built you were scattered by an explosion no one was there to record. When a massive star dies, its core collapses and rebounds in a supernova, hurling its layers into the dark. In those final hours, it forges and flings out oxygen, carbon, and the iron now circling in your blood. Astronomers can only study the aftermath, the glowing shells left behind, like SN 1987A, still expanding today. The birth of your ingredients is something we infer rather than ever witness. The light that left the death reaches us long after the star itself was gone. No telescope has ever watched a single atom of your iron being made. Stellar cores are sealed behind millions of miles of plasma, so the forge stays out of sight, even as it burns. Everything we know about how iron is fused comes from models, from the faint chemical fingerprints in starlight, and from the neutrinos that slip out untouched. Scientists are confident, yet honest, that confidence is built on indirect proof. The furnace that made part of you stays hidden, and somehow that hiddenness makes the connection feel quieter, more intimate, almost like a secret the universe kept for you. Some elements heavier than iron long resisted a clear explanation. Gold, platinum, and the iodine your thyroid needs are now traced to sources like the violent merger of two neutron stars. Yet within living human memory, the origin of your heaviest atoms was still an open question, and even now the finer details of the recipe are debated. The wedding ring, the trace metals in your cells, their full story is something science pieced together only recently. It is a quiet reminder of how young our understanding is of where you truly come from. The universe is mostly made of things we cannot name. Ordinary matter, every star, planet, and person accounts for only about 5% of what exists. The rest is dark matter and dark energy, which we detect only by their pull and their push. You are built from the small, lit-up fraction we can actually study. Far from making you trivial, this means you belong to the rare, the visible thread of the cosmos. You are part of the part that learned to look around and ask what the darkness might be. What came before the Big Bang may lie forever beyond our reach. The earliest moment we can describe is a fraction of a second after the beginning, when conditions were dense and hot beyond imagining. Earlier than that, our physics breaks down, and time itself loses clear meaning. The atoms in you trace back to that first light, yet their deepest origin sits behind a door science cannot yet open. There is a strange comfort in this. Your existence reaches back to a beginning so old that even the universe seems to have forgotten the details. Most of the universe lies forever beyond our reach. Because space has been expanding for nearly 14 billion years, there are galaxies whose light will never arrive here, no matter how long we wait. They are not hidden by distance alone, but by the stretching of space itself. The atoms in your body came from this one observable bubble, a single pocket of a cosmos that may be vastly, unknowably larger. You are a local event in something with no edges we can find. And still, you are here, awake, aware of the immensity. Whether the universe is finite or infinite remains uncertain. Measurements of its overall shape come back almost perfectly flat, which is consistent with a cosmos that goes on without end. But our instruments have limits, and a slight curve too gentle to detect would change everything. The carbon writing this thought may sit inside something boundless, or something merely enormous. Either way, the same physics that made your atoms is at work in regions you will never see. You are a small, settled answer inside one of the largest questions there is. The expansion of space is speeding up, and its cause remains a mystery. Distant supernovae, used as cosmic mile markers, revealed in the late 1990s that galaxies are flying apart faster over time. The force behind it is named dark energy, but the name is mostly a placeholder for our ignorance. It will slowly carry other galaxies out of view across unimaginable spans of time. Your atoms ride this quiet current too. To exist now, in the long era, when the sky is still full, is a kind of fortune the deep future will not share. A star cannot be rewound to watch it make you. Nucleosynthesis happens once, irreversibly, as a star burns through its fuel from hydrogen toward iron. Each step releases energy and cannot be undone, the way ash cannot become wood again. The specific star that made some of your carbon is long gone, its name unrecorded, its location lost. You carry the only evidence it ever existed. In a real sense, you are a memorial, the surviving trace of a life that ended before the Earth was even a cloud of dust. The sheer number of stars makes any precise accounting impossible. The observable universe holds an estimated 2 trillion galaxies, each with hundreds of billions of stars. Somewhere, among those countless furnaces, particular ones forged the exact atoms now in your hand. We can never identify which. The scale defeats us, yet the logic holds firm. Every heavy element in you was made in a star, and there were always enough stars for the work. You are the certain outcome of an uncountable process, rare in detail, inevitable in kind. Even our best models leave gaps in the story of how galaxies assembled. We understand the broad sweep, gas collapsing, stars igniting, generations, enriching the next with heavier elements. But the fine details of how the first stars formed, and how quickly they seeded space, remain under active study. New telescopes keep revising the timeline. The chain that ends in you is real, yet some of its early links are still being traced. There is honesty in admitting this. The lineage that produced you is so ancient that we are still learning to read its opening chapters. The first stars that started everything stay hidden from our instruments. Born from pure hydrogen and helium, these earliest suns made the very first carbon and oxygen, the seeds of all later chemistry. But they lived and died so long ago that their light is stretched almost beyond detection. We hunt for their faint signatures and have not yet seen one clearly. The ancestry of your atoms passes through stars we have never glimpsed, silent founders of a family line that runs unbroken all the way down to the breath you are taking now. Even the exact age of the universe still carries a quiet uncertainty. Our best figure is about 13.8 billion years, drawn from the afterglow of the Big Bang and the expansion rate. Yet two careful ways of measuring that rate disagree slightly. A puzzle researchers call the Hubble tension. The numbers are close, but not identical, and the gap has not closed. The atoms in you are nearly as old as time itself, and even that age, the oldest number we know, is something science is still working to pin down precisely. Whether other universes exist may lie forever beyond testing. Some theories suggest our cosmos is one bubble among countless others, each with its own laws. There is currently no way to check this, and there may never be. What we can say is that in this universe, The constants of physics fall within the narrow range that lets stars form, fuse iron, and eventually make beings who wonder about it. Whether that is luck, necessity, or one outcome among many, the result is the same. The conditions for you held, here, at least once. Notice how the question has quietly changed shape. We began by asking how the death of a star could ever make a single life feel less alone. Fact by fact, the answer has stopped being about distance and started being about lineage. The more clearly we map the limits of what we can know, the more certain one thing becomes. And the matter in you was assembled by the same processes that built everything else that exists. You are not a stranger set down in a vast and indifferent cosmos. You are made of its oldest events, still unfolding. The information about your atom's journey is mostly lost, yet you remain the proof. No record exists of which clouds your carbon drifted through or how many times it was recycled before reaching you. Each star that handled it added its mark and then dispersed. The path is unrecoverable in detail, but the conclusion survives in your body. The way a river's history survives in the stones it carries. You do not need the full map to trust the destination. The matter arrived, gathered, and became something that could finally look back along the road. When the last stars will die is something no one can predict exactly. Star formation is slowing as galaxies use up their gas, and in the far future, the sky will dim toward darkness. Estimates stretch into numbers with dozens of zeros, far beyond reliable forecasting. The era of starlight, the only era in which beings like you can be made, is a brief, bright window in cosmic time. That you exist during it, with eyes open and a mind able to grasp it, is not something the long, dark ages to come will ever repeat. The fate of the universe itself is still an open question. If dark energy holds steady, expansion continues forever toward a cold, quiet end. If it shifts, the story could close differently. We measure, we model, and we admit the answer lies beyond our current certainty. Your atoms will outlast you, drifting on whatever path the cosmos finally takes. Knowing we cannot yet see that ending strips away false comfort and leaves a truer one, this moment, with you in it, is real now. Whatever the distant future decides to become. Science cannot tell you what your existence means, only how thoroughly you belong. It can trace your iron to a supernova and your carbon to an ancient star, but it offers no verdict on purpose. That blank is not a failure of knowledge. It is a door left open for you. The facts establish the kinship. You and the stars share a single origin and a single set of elements. What you make of that bond is yours, alone to decide. The universe supplies the lineage. The meaning is the one thing it leaves in your hands. The precise boundary where stardust became someone may stay hidden forever. atoms gathered into the early Earth, into oceans, into the first cells, into you, through a chain so gradual that no single moment marks the change. There was never a flash when dead matter awoke. Just slow assembly, over billions of years, until the cosmos held a piece of itself that could feel lonely and ask why. The mystery of that threshold remains. But it happened, and the result is reading these words, made of stars and somehow aware of it. The total amount we do not know almost certainly exceeds what we do. Every answer in cosmology opens new questions. About dark matter, about the first instant, about whether our laws are universal. Far from diminishing your place, this growing edge of ignorance includes you in the greatest ongoing inquiry there is. You are matter that has organized itself into a question-asking thing. The universe spent billions of years and countless stars to produce something that could notice how much remains unknown. And you are that something, here on a quiet night. How stardust came to study itself is a puzzle we cannot fully explain. Out of the same elements that make stones and seawater, the cosmos assembled brains, capable of measuring supernovae and tracing their own origins. How matter became mind is among the deepest unsolved problems in all of science. Yet here you are, an arrangement of ancient atoms turned attentive. The very awareness following these words is the universe's most astonishing and least understood achievement. You are not separate from the mystery you are pondering. You are the form it took in order to wonder. Here is what the long night has been circling toward, drawing very near at last. You are not a small, accidental visitor in a cosmos that has nothing to do with you. The atoms it forged in stars are the same atoms now turning to look back at where they came from, and that looking is happening in you. The loneliness that brought you here tonight was built on a misunderstanding that you are apart from it all. The deeper truth is the opposite, and it is almost close enough now to hold. What has been gathering all night is nearly ready to be said plainly. The forging happens without effort now. The way a star fuses iron, simply by being what it is, asking nothing of the matter, it transforms. That same effortless making is what assembled you. No permission needed. No striving required. Feel how your body keeps itself. Your blood carrying its ancient iron. Your bones holding their borrowed calcium. All of it tended while you do nothing but rest. Something has been gathering across this whole hour toward a single quiet recognition that you were never separate, never truly alone in here. You can let the last of that worry loosen. What we have been moving toward is very close now, near enough to feel. Whether the universe will ever know itself completely is not something we can say. Perhaps every question we close opens two more. On and on, without a final page. But completeness may not be the point. Through eyes like yours, the cosmos has already managed to see its own stars, weigh its own beginning, and trace its own atoms into a beating heart. That is a kind of self-knowledge that did not exist before minds arose. Whatever stays hidden, this much has happened. The universe woke up enough to recognize a piece of itself, sitting in the dark, listening. So the question we carried in finds its clearest answer, said plainly at last. Understanding the death of a star makes your own life feel less lonely because that death is, quite literally, your beginning. And the same is true for everyone and everything you have ever loved. You are the universe itself, gathered into a single, living point of view. Using atoms it forged in stars to turn around and know that it exists. You are not a stranger who wandered into an indifferent place. To grasp this is to understand that belonging was never something you had to earn. It was the condition you were born from. The calcium holding your bones together was not made on Earth. It was forged inside dying stars, in the slow furnace of their final million years, then scattered when they collapsed. Every skeleton walking the planet tonight is built from the ash of stars that burned out long before the sun was lit. You are not visiting this universe. You were assembled from the oldest parts of it, and you have always belonged. The iron that turns your blood red came from one of the most violent events the cosmos allows. When a massive star runs out of fuel, its core collapses in less than a second, then rebounds in a supernova that floods the dark with sudden light. In that flash, iron streamed outward across light years. It eventually settled into a cloud, into a planet, into a vein near your wrist, quietly carrying oxygen while you rest. Almost all of your body, measured by weight, was made inside stars. Only about 1/10 of your atoms are hydrogen from the first minutes after the Big Bang, nearly 14 billion years ago. But those atoms are so light, they add up to little of your mass. The heavier elements that give you weight, the carbon and nitrogen and oxygen and calcium, were cooked in stellar cores. You are, almost entirely by mass, recycled starlight wearing a temporary shape, and tonight that shape is finally allowed to grow still. The atoms in your right hand may have come from a different dead star than the atoms in your left. Stellar material mixes across enormous distances before it ever forms a planet. So your body is not the product of one ancestor in the sky, but a gathering of many, drawn from scattered corners of the galaxy. You are a meeting place, a quiet reunion of things that were once unimaginably far apart. Every carbon atom in you exists because a fleeting nuclear accident inside a star happened to succeed. 2 helium nuclei briefly stick as unstable beryllium, and a 3rd helium must arrive in the instant before it breaks apart again. The odds are tiny, yet stars are patient and vast. Over deep time, enough carbon was made to build forests, oceans, and you. The improbable became your hands, your heartbeat, your breath slowing now. The same kind of atoms in your body are found in distant nebulae thousands of light years away. When astronomers study the glowing gas of star-forming regions, they detect the signatures of carbon, oxygen, and nitrogen, the very elements inside you. You are not separate from those luminous clouds. You are made of the same alphabet, spelled into a different word, here on a small blue world for a little while. Your body holds atoms that have existed for billions of years and will outlast you by billions more. Atoms are not consumed by living. They are only borrowed. The oxygen you breathe out tonight has circled through ancient seas and prehistoric lungs. Nothing about you is truly new, and nothing about you will truly end. You are a passing arrangement of something far older than any loneliness you have felt. The gold and silver some people wear were made when neutron stars collided. These collapsed stellar cores, each heavier than the sun, yet smaller than a city, occasionally crash together and release a burst of heavy elements. Those metals drifted through space and seeded the cloud that became our solar system. Even the rarest things on Earth carry the memory of catastrophe and creation happening at once, very far from here. Each second, trillions of neutrinos born in the sun's core pass straight through your body without a sound or a touch. And far more rarely, a few from ancient supernovae drift through as well. They are messengers from stellar cores, both living and long dead. As you lie here, the deep machinery of the cosmos is passing gently through you, asking nothing, simply on its way. The sun itself is recycling the universe in slow motion. Deep in its core, hydrogen fuses into helium, releasing the light that warmed your skin today. In a few billion years, it will swell, shed its outer layers, and enrich space with new elements. The star that feeds you now will one day become the dust that feeds whatever comes after. Even our own star is part of the great handing on. Your atoms have been part of countless other things before they were you. The same nitrogen may have been a fern in a swamp, a drop of rain, a feather, a star's outer shell. Matter never stops moving through forms. To be alive is simply to be the universe arranged this way, briefly, before it becomes something else. There is no edge where you stop and the cosmos begins. The Big Bang did not happen somewhere far away that you could point to. It happened everywhere at once, including the exact space your body now occupies. The expansion that began nearly 14 billion years ago is still unfolding through the room around you. You are not watching the universe from outside. You are sitting inside the ongoing aftermath of its first moment, made of its earliest light. Stars do not waste anything when they die. The heavier elements they create are flung outward to become the seeds of new stars, new planets, and new life. Death in the cosmos is never an ending. It is a redistribution. Some of those scattered atoms found their way into the marrow that makes your blood tonight. You exist because something enormous let go, and let itself become everything that followed. For 13 billion years, the matter drifted and gathered with no one to notice it. Atoms learned to form stars. Stars learned to forge elements. And those elements eventually shaped the quiet mind, now following these words. Whatever awareness you feel tonight is rare and recent. A soft light kindled late in a very old dark. It cost the cosmos an unthinkable stretch of time to make something that could simply lie here and feel itself breathing. So when the night sky makes you feel small and alone, consider what the smallness is made of. The same forces that built the farthest galaxy built the bones holding you steady on the bed. There is no true distance between you and the stars. Only the same substance wearing two different faces. Let that quiet kinship soften the ache, and let it settle you toward rest. Even the water moving through your body is older than the sun. Much of Earth's water formed in the cold clouds of interstellar space long before any planet existed. The same molecules now flowing in your blood once drifted between the stars. You are not only made of starlight, you are made of the patience of deep space, carried gently inside you while you breathe. The light from some stars you can see tonight left them before humans existed. By the time it reaches your eyes, that star may have already died, scattering new atoms into the dark. So when you look up, you are seeing the past and the seeds of the future at once. The sky is a long, slow story, and you are one of its newest pages, written in elements it made. There is no clear boundary between your body and the cosmos around it. You are constantly exchanging atoms with the air, the food, the water, the light. The line you imagine between yourself and everything else is softer than it feels. You are a current in a much larger flow, and tonight you can let that flow carry you, instead of holding yourself apart from it. The carbon in your DNA, the very code that makes you uniquely yourself, is starborn. The instructions for your eyes, your voice, your sleeping face were written in atoms forged across many stellar lifetimes. Your individuality is not separate from the cosmos. It is one of its rarest creations. You are both a particular person, and an expression of something that has been unfolding since the beginning. Astronomers estimate the universe holds more stars than grains of sand on every beach on Earth. Each one is a furnace capable of making the elements of life. Out of that uncountable abundance, the atoms that became you were gathered into a single, breathing form. You are not lost in the vastness. You are one of the precise, improbable ways the vastness took a name and a heartbeat. Everything you have ever loved is made of the same stardust you are. The people, the faces, the warm hands, all of it is woven from the same cosmic material gathered across deep time. The connection you sometimes ache for is not something to find. It is already true at the level of atoms. You have always been related to everything, formed from the same ancient and generous source. When your body eventually returns its atoms to the world, they will not vanish. They will move on into soil, air, water, and one day perhaps into new stars. The matter that is you tonight will continue the same journey it has always made, through form after form. You are part of a cycle with no real end, only the endless, quiet handing on of everything that exists. The space between distant galaxies is still stretching wider tonight, carried by the same expansion that began everything. The cosmos is not finished. It is still becoming. Neither are you a finished thing, set apart and merely watching. Your quiet breathing in the dark is one small motion of a universe still unfolding. Your existence is not an accident dropped into the story. It is the story continuing through you. Every breath you take draws in atoms once breathed by ancient seas, by forests long gone, by countless living things before you. Each breath returns them to the world to be breathed again. You are not a closed and separate self. You are a passage the universe moves through, an exchange that has been happening for billions of years and is happening softly, right now in the dark. Rest now, knowing you are not a small and lonely thing, adrift in an empty sky. You are ancient dust that learned to love, to wonder, and to rest. The universe spent 13 billion years making the stars, then making you, so that for a little while it could feel what it is to be alive and held. Tonight, you can stop searching for your place in it all. You are already home, and you always were. The atoms in your blood were once the iron of a star that tore itself apart, and the calcium in your bones was scattered by a dying furnace older than the earth. Somewhere along the way, the universe spent 13 billion years arranging that scattered material until it could finally open its eyes and look back at the sky. The space your body fills now is the same space that held the first moment of everything. Across all of it, from the supernovae to the slow drift of water between the stars, one quiet truth has been gathering, fact by fact, all night long. You came here, perhaps feeling like a single small figure beneath an indifferent sky. And you can leave, knowing that the sky and the figure are made of one another. The distance you felt was never real at the level of atoms. If, somewhere in this long journey through the stars, the loneliness loosened even a little, then these nights of cosmic wandering may be worth keeping close. You might let this channel stay with you, so the next quiet exploration of the universe can find you when you need it. It is made for anyone who lies awake, feeling far from everything, and hopes to remember they belong. Picture the slow, patient drift of stardust gathering across deep time, settling at last into the shape of a resting body. That same gathering is what holds you together now, every borrowed atom quietly in its place. Let your entire being dissolve into that ancient, drifting dust, the way a single grain settles back into the vast cloud it came from There is nothing left to prove, and no place else to reach. You were always part of this, and now you can simply be part of it. At rest. Let yourself settle the way. Scattered matter settles into a new star, drawn together gently by something far larger than effort. There is nothing to gather and nothing to hold. The work of becoming has already been done in you. Feel your breath slow and lengthen, each one older than the sun, moving through you without your help. Let sleep arrive, the way starlight arrives after its long crossing, unhurried and certain, asking nothing of you at all. The Dream Science playlist has been carrying minds gently out into the cosmos, one quiet night at a time, and the next journey is already taking shape in the dark. That story is waiting whenever you are ready, with new wonders made of the same ancient dust. For now, let your eyes stay closed, and let the night hold you exactly where you are. There is nowhere you need to travel tonight. Rest now, gentle soul. You are ancient dust that learned to wander, and you have always belonged among the stars. Sleep well beneath the quiet sky. Good night.